Hello, Mischa Dohler here. I'm professor at the engineering department of King's College in London. And I thought to give you a little bit of an overview of the research we're doing on digital technologies such as 6G as well as smart cities. Now, my personal relationship with the digital world and with the cities world actually stretches back, almost 15 years now. And notably, I've been very active in all things smart cities through my company, World Sensing. We have pioneered loads of the notions which are being used today within the context of smart cities, such as smart parking and other things. And at the same time, being professor in all things digital, we work very strongly on the 4G, 5G, and now 6G developments. So I thought combining both and just show you a little bit on how I personally think, that ecosystem will evolve. So let's get on with that and see whether 6G and smart cities actually have any synergies. So here's a slide which I've actually been using over the last maybe 10 years, and it hasn't changed at all. And it is really to show you that when we talk about smart cities, we still have a very big divide between smart and city. So we have on one end all the digital things, IoT, sensors, actuators, 4G, 5G, hopefully in the future 6G, all the artificial intelligence, data platform, other, edge cloud compute capabilities and all that. And on the other side, we have city, meaning roads, streets, traffic lights, parking meters and all that. And whilst, both are coming closer, I still see that, the city people not necessarily speak the smart language and the smart folks not necessarily speak the city language. So we still have that chasm between these two worlds where, we don't really yet have a smart city. We have smart and city. And I think, one thing we still need to do to bring these ecosystems together. And let's see if we can get it going through one of the things I wanted to do for many, many years. And that is to completely transform mega cities. And the idea is really to get rid of all the cars, all the transports, all the buses, everything which runs on the roads, and replace that really by pedestrian areas, bicycle areas. Now, the inspiration to this came maybe 10 years ago when I was by total coincidence in Israel at Yom Kippur. And those who know about Yom Kippur, they know that essentially, it's a very big religious festival for the Jews, and Israel just stops functioning. Even the airports, nothing works. So I was there with my friends on the highways in Tel Aviv, barbecuing. And I just thought, this is phenomenal. Pollution's gone down. People started to truly re-own their urban infrastructure. And I remember I flew back, and back then Boris Johnson was still our mayor. And we talked to him about it, and he then promised to look into this for London and introduce the last weekend in September a car-free scheme. So this is how it all started. But of course, it's just one day, and I wanted this for a longer period. And of course, there are cities who are doing that already. So there are quite a few cities out there, but there's no mega city. There's no London. There's no Buenos Aires. There's no New York. There's no Beijing or Moscow, Berlin, who are really going fully green, completely get rid of cars. So this is really what we wanted to do. And I started to study it from all the possible angles to figure out whether this is actually doable. And if we wanted to do that, we actually really needed to make sure that cars, ambulances, buses, motorbikes would transit to trains, underground, cycles, walking. And the same is not only for the citizens, but also for the industry. There's a lot of stuff happening in a mega city. The supply chains, there's construction, there's a lot of, waste management going on. There's a lot of stuff going on in an urban city the size of London. And therefore also that needs to be transited into a more sustainable form. And I figured, once we really manage to do that, and if we are managing to do that, what would that lead to? It would essentially allow us to have many more people cycle, many more people walk, and people not being afraid to cycle, because it turns out, a study has been done recently by the Bicycle Association here in the United Kingdom. People are afraid to cycle because there are too many cars and buses and trucks and all that on the road. It scares people. Naturally, we hear about a lot of deaths, accidents. So if we got rid of all that heavy duty four-wheel type of traffic, wouldn't it be great then to liberate that space for cyclists and for pedestrians? Now, we all understand that pollution will go down, so that's a huge health benefit. People will walk more, will exercise more, which is yet another huge benefit. So therefore, the bottom line cost and the top line opportunity, business opportunities, seem to be a no-brainer. So we started thinking on how to do that. And the way we think this can be done is, by addressing three challenges. And these challenges are in urban engineering, in transport engineering, and in digital engineering. So these three things. And I will talk you through each of these because we looked at each of these. And of course, I'm really a designer very deep in the digital engineering side. So let's start with the urban engineering. Now, I have to say that I'm not an urban engineer, so this is really just looking conceptually at what could be done, and then the real professionals, the real urban engineers, should take over and essentially do that properly. But here's some outline, just some ideas on how we could approach that problem. Notably, we looked at a citizen's life in general. What do people do in a city like London or New York or Beijing, as an example? So clearly, we wanted to understand, how easy is it for people to access the underground? So the underground transport, of course, should be there because it will absorb a lot of the overground, traffic, which we are now trying to get rid of, in a sense. So, how easy is it to get to an underground from any point in the city? How easy is it to get actually to a city biking spot? There are loads of them in big cities now where you can rent these bikes and then really cycle through the city. So how easy is that? And then what shall we do in very special situations? Weather is bad, or emergencies need to be dealt with. So this is how we looked at it from a citizen's point of view. And then of course we need to care for the disabled and the elderly, because there will be quite a few people which need extra help, and they have been very reliant on buses and taxis before. So we started to look from a capacity analysis, purely capacity, as a macro view in the city like London. We said, what's the bus usage today? What's the car usage today? What's the underground and train usage today? And what's the capacity around this? And could we make use of, rivers or airspace? Flying taxis are coming. Couldn't we use that? So we did that capacity analysis, and then we also looked very, very diligently into the reduction on emissions. So how much health benefit do we get from an air quality point of view? We also looked at the exercising benefits. So I will not present all of that because there's quite a bit of stuff. I'll give you a few snapshots of the work which came out of that. So here's the example of the accessibility in underground. So we used a tool called MATLAB, and we spatially mapped all the underground stations, and then we just run a random point model where people could be. We haven't even used a true street model. So in fact, the analysis we have here is probably a worst balance. So we found out that from any point in central London, so we looked at zone 1 and 2 here, we didn't go into the further zones, so we really focused currently at the core of the nucleus, of the urban nucleus. And we found out that from any point, you find at least one underground station within 10 minutes walking. Okay, so no matter how hard you try, within 10 minutes you can reach an underground in London within 10 minutes walking. So that's really great. With bicycle, you'll be even quicker, and in most of the cases, you will be even quicker than these 10 minutes. So that's about 10 minutes. And then we look, what about 2 or 3 stations? So you see the result here for 2 stations within 15 minutes. You have at least 2 underground stations, so you have a little bit of choice there. You don't necessarily need to change the underlines underground. So that's a great result, because 10 minutes walking to an underground is really not too arduous. You can do that. You can expect that from the citizens, which aren't the elderly and the disabled. We then did all that capacity calculus, and we figured out, actually, guys, it's doable. It's really doable. So we worked out, what's the bus capacity at the moment, sorry, the bus usage at the moment, the car and taxis usage today, and we came up with this nominal number. You see it on the screen, 45,249. So this is a number which is a special unit we created. It's a certain number of passengers or citizens per time per area. And then we looked at, the increase based on the past increase of that number. We have seen that this number increases about 1% per year. And we figured out that, the true capacity on the train undergrounds and train lines is 54,000. And at an increase of 1% per year, you suddenly have a crunch in the year 2039. So therefore, this was done pre-COVID, not doing any investment into trains and undergrounds, with the current infrastructure, just removing all the buses and the taxis and the cars in London, you'd be able to run until the year 2039 without really hitting capacity crunch. That's great. It's 20 years to go. Okay, it's 20 years to go, and we can imagine there's more forms of transport appearing, such as air taxis and rivers. The rivers being used a bit more. We can also think of more investment in the underground. So it is really doable. We can push this number probably to many years ahead, but 20 years ahead seems to be very good. It's doable. So we can do it from a capacity point of view. We then also looked at the industrial aspects. Of course, the city is not only people. We have supply chains there. We have construction there. We have, various, services running within the city, which now also need to be replaced. So first thing we examined is if we couldn't just shift them to the night. So one thing we have been looking at is to see, what happens if we actually start, using some of these supply chain service, construction services, let's say from 10 o'clock at night until 4 o'clock in the morning or 5 o'clock in the morning. So there's a working shift clearly from the people involved, but it would liberate the roads and the streets in London during daytime. We also looked at the parcel delivery. We looked at waste management. I will not talk much about this, but we have done the exercise and we figured out it is actually doable. An example here from a supply chain point of view, we looked at the warehouse distancing. So the same as we've done with the undergrounds, we looked at the warehouse distancing and how could you reach it in the form, if you had to do it during daytime, how quickly can this be done? And we figured out within half an hour using, transport modes which aren't trucks or which aren't, the wide vans which are typically being used. And I'll show you some solutions later on. You can reach any of these points within 30 minutes, which is great. So it's doable. It is not really a huge challenge to address that. And also remember, folks, we can have the city run at night where basically we expect nobody to be on the road from a cycling point of view. So then we looked at the transport engineering challenges. What could be done there? Now, again, I'm not an expert in transport engineering at all, but we started looking at this. So we didn't design flying taxis. We didn't look at special ways of using the river, but we had some other thoughts which we thought would be very low-hanging fruits of making. We thought specifically about the elderly and disabled. So there are tools coming out now where people can really, move through the city on trolleys. They're very slowly moving on wheelchairs, automated wheelchairs. How do you absorb them now into the underground? How do you make that happen? So, instead of constructing more step-free underground stations, so how to keep the investment low, we thought of modifying, let's say, the escalators or introducing wheelchairs which are able to actually go down on escalators. So we've done that. We've done much more. It's just a little snapshot there. So an example I'm giving here on how to deal with the elderly and with the disabled. Another example we looked at is how to improve this space in the underground. So rather than having seats everywhere, we thought of keeping seats for the elderly and for the disabled, and those are very tired, women who are pregnant, people in need who really need to sit down after maybe a 10-minute walk to the underground. And we figured out that if we start removing seats in certain parts of the section, we are suddenly opening up a capacity which is phenomenal in the underground, allowing more people to travel. Now, this, of course, this design was pre-COVID. So therefore, we assume that at some point the COVID crisis will be dealt with, and also the traffic, probably the density of people in the city is much lower now. But we just wanted to show it's possible to increase the capacity of the underground itself. And also we designed, now I see the underground, we designed essentially parcel sections where part of the one wagon of the underground is being used to essentially ship goods through the city, post, parcels, etc., which could replace some of the overground, deliveries. We also looked at new cargo bikes. Don't laugh about this, but we thought let's just give it a go. 4 cubic meters, that's phenomenal. That's really a lot. So we looked at it from a design mechanics point of view, and you see something here on the screen. I'll leave that to the real pros. But in principle, 4 cubic meters is a lot of space, so you can really load a lot of parcels in there, a lot of goods. You see some of these already being used at smaller form in London, such as Pret-a-Manger has been doing that to have a more green form of transport between their shops and kitchens. And we thought of expanding that, making it bigger, and essentially be driven by green energy to get goods from one part of the city to the other part. So let's make an interim conclusion here before we move on to the the digital side. So it is doable, folks. It's doable. A city like London can actually go entirely green. We can make sure that there are no cars, no buses, no taxis, no 4-wheelers, 6-wheelers, 10-wheelers on the roads during daytime. Nighttime, very specific nighttime is a different story, but during daytime this is doable. We can make it work. There are enough underground stations there within walking distance. There are enough biking stations in there within walking distance. The underground does not saturate, until 20 years from now, and that is a pre-COVID estimate. So, and this is also assuming there's no investment going on. We also are able to see that a huge amount of carbon dioxide will be reduced, and the pollution in general will go down. And remember that it's not only the exhausts which provide the pollution, it's also the wheels of the cars, which during braking release a lot of these toxic materials, something you will see much less with cycles. So therefore, a huge amount of toxicity goes down in the cities. People will be healthier, the load on the NHS will be lower. There are challenges to be overcome, habits to be overcome, but it is doable from a citizen point of view. Industry will push back naturally, so there's a lot of things we haven't looked at, for instance, what to do with the, tens of thousands of taxi drivers in the city. They need to be retrained probably. We need to come up with new schemes there. But in principle, the big industry, supply chain, construction, parcel industry, all that is doable. We can do that. We've worked out schemes. We looked at capacity, and we are able to run London during daytime without vehicles. Opening up the space to people. People can have barbecues again on the roads. They can go with cycles, with their children, with their pets. Nobody should be afraid to be on and own that public infrastructure. So that's quite exciting. So let's move on now to the digital side. Now, from the digital engineering point of view, of course, that becomes very interesting because we will clearly change the the demographics in the city, and COVID has accelerated that even more. And there will be huge changes in working patterns, commuting patterns, being at home patterns, and therefore the big. Now, before I start doing this, let's look at the trends, and that's quite an important slide actually, and hopefully it's quite helpful to you as well. And this is how I like to see my ecosystem, the telco ecosystem. And you can see that as we went from 1G to 2G, 3G, 4G, 5G, now 6G, telco always follows that very constant trend. It almost seems to be a law similar to Moore's law, but just for telecom. And something always improves by an order or 2 orders of magnitude, whether that's the data rate or that's the latency or the reliability or how many devices you can connect. So it is always improving very reliably. So you see essentially that arrow there going up, that black arrow, and as we went through time from 1G now to 5G, we started to be able to serve different communities. So, 2G, 3G, 4G was mainly about people. We went from voice call, to an internet, to truly flat internet, really highly performant internet with 4G. And with 5G now, we start to see that the KPIs are so good, so brilliant, that we're able now to serve not only the citizens, but also industry. And the reason is because mainly it's the reliability really gone up. It's really good reliability, but also the latency has improved now to an order where it becomes interesting to replace some of the industrial Ethernet cables we see in manufacturing halls. So with latencies of a millisecond, or maybe up to 10 milliseconds we observe in 5G, suddenly you can get rid of cables in manufacturing halls and therefore save a lot of cost. You can have 5G plugged in an edge cloud, actuators and sensors work in unison to design your perfectly, a personalized car. And these type of things we can do these days. And car maybe is a bad example because I'm trying to get off cars. Let's say bicycle, right? So you're perfectly kind of personalized bicycle. So these type of things we can do now with 5G. And, if we believe the trend, 6G will improve on that. And I put a blue box up there because maybe we'll be able to serve something else. I have some ideas what that something else might be, but we are seeing, we are now chartering into new territory. I would also like to for you to pay attention to another set of errors I drew down there, which are the blue errors, which always draw from 1G to 2G, 3G, 4G, 5G to 6G. So essentially from the uneven or the odd generation to the even generation, and this is because it seems like it always takes us about one generation to truly embody what we wanted to do with the previous generation. So in 1G, we wanted to have this global calling, untethered calling capability. It was a starting point, but we wouldn't call it a success. The success was 2G. Okay, it was really 2G. In 3G, we wanted to introduce the internet to the mobiles. It was a first step. I wouldn't call it a success. 4G was a success. So when you have your 4G phone today, when I'm using my phone today and I have 4G, I forget I'm on 4G because the connectivity is so good that actually it's just a truly seamless experience. Now in 5G, we start to bind in industry, and these will be very first steps, and they're important steps. You can't take the subsequent step without doing the previous one. So we need 5G, but it will really be 6G, which will then kind of embody that full capability of the industry, which we have on industry connectivity. So I just wanted to show you these two trends. So there's really regularly increasing trend, as well as that consolidation trend from the odd to the even generations. Now with that at hand, we are now able to really understand what is 6G going to be about. So when we look at it, what was 4G, what is 5G, what's 6G, you follow the trend, you can do the exercise, right? You can do it. I show you here, for instance, the average experience data rate by a user in 4G was 10 meg, in 5G it is 100 meg. So therefore we know by virtue of the trend, we multiply the 100 meg by 10, and in 5G might be called IMT 2030. I don't know yet. I made up this name, but in 6G we will have 1 gigabit per second, right? We have it. Latency, the user plane latency, so meaning the time it takes for you to press a button and get the response from the website, or to get your sensor react or your actuator react to some sensing input, will go down to 0.1 milliseconds. And there will be other KPIs which will improve. I won't spend time on this, but you get the gist, right? So we know how 6G will look like. We don't know why it should look like this, and we have no idea how to do it. Okay, so that is now the road we need to do over the next years as engineers to come up with that, and the business people need to come up with ideas. But I want to quote a really good sentence I borrowed from Hans Vestberg, the former chief executive of Ericsson and now chief executive of Verizon, and he said, "Look, guys, we started designing 3G when the internet wasn't around. We started designing 4G when the iPhone wasn't really around. So therefore, don't get too bogged down. What's going to be the killer app for 5G, 6G, etc. It will come. We shouldn't worry about it. We know we need to deliver it for 6G, a gigabit per second. We still don't know exactly how. We have ideas, but we don't know exactly how, and we still don't know why. But we don't panic because we know the why and the how will be answered." So what is happening then from a application point of view? So we published pre-published a really interesting paper. You see it here with my co-authors, friends, and colleagues around the world. It's called 6G Wireless Systems: Vision, Requirements, Challenges, Insights, and Opportunities. And it is leveraging on this trend, essentially showing, what will we consolidate with 6G, what we started excitingly with 5G. And you see a lot of items on here, and you see a lot of KPIs here, data rates, reliability, and you will see it has been multiplied by 10 or divided by 10. But I would like you to look at that smart cities, icon, because we believe that really 6G will be an instrumental, technology within smart cities, an aggregator of a lot of data, the ability to process that data, so essentially consolidate what we wanted to do with 5G and the IoT ecosystem. So therefore, we believe 6G will really be instrumental. It will bring, really that immediacy, hopefully, that immediacy which we have been dreaming of for so long. Let me really kind of spend a bit of time on this one, and it's really, show you what kind of what possible applications we have there in the cities. And I'm cherry picking here a little bit, but those who know my work, they know I've been dreaming of this new internet. This new internet which comes as a natural sequence of the traditional internet, the mobile internet, the things internet, or internet of things as we call it. I wanted to have an internet of skills. So I believed in 5G, now 6G, being able to democratize skills the very same way as the internet has democratized information. And you see here on that slide with a lot of coverage down this work, and I wanted to drift away a little bit from this Industry 4.0 thinking where we are essentially empowering machines. I really wanted to empower humans, you and me, anybody who has a talent in any form. Could we transmit that talent? And it turns out, with 5G, 6G, we're able to do that. Think of it like a digital twinning, a teleportation of your skills. But, the idea is to bring you very, very close to a level of immediacy in a full immersive type of environment to any other place in the world. We can think of, the Rolls-Royce or, the Vauxhall engineers, the Tesla engineers being in their factories or at their home even, in helping maintaining the engines or the cars, the machines, everything, remotely. We can think of this scenario like that, or somebody teaches me how to paint without actually being with me, or I teach people how to play the piano. So that Internet of Skills vision really requires, this low latency network, which will, I think, really be consolidated with 6G, and that will change entirely the demographics in the city, because a lot of the commutes will really fall through. You will be able to do things, from your home, maybe from an office which is nearby. So therefore that dynamics will change. And we will start introducing what we call a holographic society. So what happens if you start fully holographically mapping the environment? Well, you need to transmit, 4.32 terabits per second. Now, this is a terrible data rate, really. We will have new ways of dealing with that, and we've seen recent announcement by NVIDIA to use AI to essentially predict a lot of the visuals on both ends. So this will come down, but clearly, new forms of engagement in the urban environments powered by the Internet of Skills and holography will allow us essentially to unlock entirely new services and change the demographics in urban environments. So it's really that 6G will probably be at the dawn of a very human-centric era. It's really about us humans, Internet of Skills. It's really about you, me, anybody in the world democratizing their skills, very human-centric. It will be underpinned by loads of machines, artificial intelligence, and it will, facilitate these yet-to-be-designed applications and services. And the interesting thing is also, because a lot will be driven by AI and by, machines in general, these services will likely be generated on the run. So we're not talking anymore about a very discrete set of services we are used to. We're talking about a spectrum of services, services which might be ramped up in a millisecond and then ramped down a millisecond later. So we will have that type of ability of the network, which overall, as an aggregate from a macro point of view, will support, a human-centric era. So that's really it from my end. And I'd like to thank you to stay with me for that mini keynote here. You're most welcome to contact me on the various aspects I've talked about. But let's work together to make our cities, our big mega cities, truly green again. Thank you and greetings from London.